These are footage from an aircraft repair plant in the city of Zaporozhye. In the Soviet era, this plant repaired and modernized different types of aircraft. Since 1978, it has been focused on repairing the MiG-25s. After the collapse of the Soviet Union, this plant, which temporarily found itself on the territory of Ukraine, continued to repair Russian planes and aviation equipment under an agreement between Russia and Ukraine. Meanwhile, at the beginning of the new century, Russia decided to gradually complete the operation of the MiG-25s. It was a sad time for the Russian military aviation. It was intensively reduced, aviation regiments were disbanded, and airfields were abandoned. At that time, there were 7 Russian MiGs. In 2003, an agreement was reached with Ukraine that the Russians would remove all the equipment from this aircraft, as well as from some other aircraft located at the plant, and take it to Russia, while the airframes would be disposed of on the territory of Ukraine. This agreement was not fully implemented, and in particular the MiGs remained at the plant. The Annex number 2 specifies everything that is removed from Tu-95s and MiG-25s. This list includes 753 items related to the MiGs. Not only engines, pumps, all kinds of sensors, valves, cylinders, taps, filters and so on, but also landing gear and control surfaces. That is flaps, ailerons, horizontal stabilizer and rudders of vertical stabilizers. The remaining weight of the plane is equal to 8,500 kilograms. 7,400 kilograms of ferrous and 1,100 of non-ferrous metals. This is the weight rounded up to 100 kilograms. However, this weight includes the weight of the hydraulic system pipelines and electrical wiring that remained on the aircraft. If we add to this 8,500 kilograms the weight of the engines and everything else that should have been removed, as well as oil into the hydraulic system and oil tanks, and coolant, the total weight will be 20 tons. This is the weight of an empty aircraft. This is the lowest weight and the better structure to fuel weight ratio among all combat supersonic aircraft of this weight class. The closest one to it, the F-111, has an empty weight of 21,500 kilograms. The Western combat aircraft with the closest empty weight is the F-14D. Its weight is almost the same, 19,855 kilograms. Of course, these are two different aircraft designed for different operating conditions. It is incorrect to compare them directly, and I do not have this goal. The main conclusion that can be drawn from this is that the designers of the MiG-25, by using the idea of load-bearing fuel tanks, welding in unprecedented quantities, and new ductile steel alloys, have achieved outstanding results in solving the problem of reducing the weight of a steel aircraft. The ratio of the weight of an empty aircraft to the weight of the structure is approximately the same as that of the F-15, made of aluminum and titanium. That is almost 50%. Comparison of the structural weight of two aircraft with approximately the same takeoff weight and internal volume, the aluminum B-52 and the steel B-70. The structure of the first weighs 37 tons, the second about 59 tons. This weight gain seems natural when switching from aluminum to steel. It seems impossible to avoid it, but this problem was solved in the MiG-25 design, which in terms of weight perfection is a worthy successor to the steel Il-2.
But the takeaway here is that in spite of all of that armor, the IL-2 wasn't all that heavy, and that's really the brilliance of Ilyushin's design.
It must be said that the MiG's lightweight non-standard design was very durable. The flight accidents from which it recovered safely indicate that it had a greater margin of safety than the other aircraft. I've talked about this before, now I'll briefly repeat. Not only did it not collapse at 11 G load, that is about 2.5 times more than the operational limit, but it continued flying without any changes, and the pilot did not even feel that the plane was damaged. The deformations were not set only after landing. It maintained an indicated airspeed of 1,600 km per hour, that is 400 km per hour more than the operational IAS limit, and continued operation. Once it endured a roll rate of 540 degrees per second at a permitted 90. The MiG-25 was a pioneering aircraft, the creation of which was a challenge for both aviation science and the entire industry of the Soviet Union. In order to create it, the work of great designers was not enough. New materials and new means and methods of production were needed, because it was impossible to produce it with the available technical equipment and methods, let alone launch mass production and produce more than 1,100 aircraft at a rate of up to 90 per year. The structural elements of the first aircraft were built at the machine building plant in Dubna, transported to Moscow, and the aircraft were assembled at the Zenit plant of the Mikoyan and Gurevich Design Bureau. The first 4 aircraft were assembled there. The elements of the 5th aircraft were sent from Dubna to the Gorky aviation plant, which subsequently launched mass production. It was the Ye-155 R3, which set many world records. The labor intensity of the very first aircraft was 1,200,000 man-hours. The last aircraft manufactured in Dubna required 700,000 man-hours, while by the end of serial production the labor intensity had decreased by an order of magnitude.